Hey guys, welcome to Safi Mixed. In this video, I will let you know a trick of vector algebra to be used in finding unknown vectors from certain vectors equations. So to this end, let me first introduce the set of vectors I'll be using in this video. We have three vectors a, b, and x. So I'm using x, which means this is unknown vector, and we have a quantity like g, which is a scalar, and then these quantities are linked through two different equations, one in the form of vector product, which is equal to vector b, that is the vector product of vector a and x equals b, and I call this equation 1, and the scalar product of these two vectors equals the scalar g, and I call this equation 2. And we want to find vector x from these two equations. If the quantities involved in equation 1 and 2 were not vectors, then we know solving these two equations for x was quite easy. But being vectors are dealt through its own algebra. Therefore, we need the tricks of vector algebra to find x, and that goes like this. I first take the vector product with the left side of equation 1 with a, that is, I want to construct this vector triple product, and using the bac-cab rules for vector triple product, I can write this thing into the form of two terms. This is the first term and this is the second term. That is, the quantity inside the brackets at this position is a scalar, which is verified by equation 2, and similarly the dot product of a vector with itself is a scalar, which is equal to the square of the magnitude of the vectors. So using these relations, I can put this equation into this form. That is, I can use equation 2 to write this thing as d and this thing as a squared, and now I have a vector equation, and I call this equation 3. Now I again consider this side of the equation, but now implement equation 1. By doing so, I can write the right side of this equation in the form as a cross b, because we know that a cross x equals b, and that's obvious from equation 1. Now we have two equations, equation 3 and equation 4, whose left sides are same. That means I can compare the right sides of equations 13 and 14 with each other, and in doing so, I first write this thing to the left and this to the right and construct this one equation. Now I multiplied this equation by minus sign to make this second term positive, and then taking this term to the right of this equation, I can rewrite the equation into this form. That is, a squared x equals d times a, which I am taking this to the right, and I have multiplied this whole equation with minus sign. Now the coefficient of vector x is a scalar, that is the square of magnitude of vector a, and we know we can divide any vector equation by scalar. So dividing both sides of this equation with a squared, I can put this equation finally into this form. That is, vector x equals 1 over a squared into d times a vector minus the cross product of a cross b. So now you see vector x is completely represented in terms of vector a, b, and d. So if we know about vectors a and b and scalar d, we can completely specify vector x. Thanks for watching.